What's up, it's Swervo here with another video. In today's video we're going to be looking at what's called the, um, basically it has kind of a fancy name, but it's called the segment addition postulate, which basically says that when you have a line segment like this, where there's a line segment QS with some point R in the middle, this piece QR plus RS equals QS. So the distance QR plus the distance RS equals QS. In this case, we have the total distance is 14, and that would be equal to QR, which we're trying to figure out, so that's the question mark, plus 6. So you're trying to think, what plus 6 is 14? Well, it's going to be 8. Okay, so we would say QR is 8. A little thing about notation, I'm usually not very picky about this. When you see QR, this is talking about the actual segment QR. When you see QR without the line over it, it's talking about the distance QR. Again, if you put a line over it, I'm not really going to care. That's just a little thing about notation. All right, moving on. I'm not going to do all of these, but I want to kind of give you, get us kind of familiar with them. But same thing here. Total distance is 6. We have EF and FG. We know FG is 2. We're trying to find this distance, which we can kind of do this in our head. That's going to be 4, right? Because 4 plus 2 is 6. All right, so the first few are kind of easy like this, and the assignment I gave you in class is going to be similar. So I'm going to move down to number 5, where it gets a little bit trickier. So here we have, the points are left off, but so we have a segment now with 2 points, and we know that, well, in fact, this information really doesn't affect us, right? Because if this PR is 18 and PQ is 8, we're looking for QR, so it has to add up to 18, so this would have to be 10. Oh, it is, I read the question. See, I didn't read the question. It's telling me to find QS. Oh boy. So I did need to find QR, but now I'm going to find QS. So they're asking me for this distance, which once I know what QR is and I know what RS is, I can add them together, because this piece plus this piece is going to add up to the whole thing. So that's going to tell me that QS is 21. All right, let's maybe do number 7 here. If you want to try these other ones on your own, pause the video. I encourage you to try them. Or pause the video here and try to do 7. So let's see here. It wants me to find EB, the total distance. So if this is 7 and this distance is 16, well then ED is going to be 16 minus 7, which would be 9. And very similar, DB is 16, DC is 7, so this distance CB is 16 minus 7, which is again 9. So it turns out EB is congruent to CB. I'm sorry, I said that wrong. ED is congruent to CB. And now I want the total distance, so I add all this up. 9 plus 7 is 16, plus 9 is 25. So 25 is equal to EB. You know what? I'm going to keep this video a little shorter. I think you'll be able to do numbers 6 and 8. I'm going to go to the back side where they get a little trickier with some variables. So let's take a look at number 9. Once again, I encourage you, as always, to pause the video and try it on your own first. So hopefully you had a chance to at least try this one. We are going to solve for x. So let's see here. Okay, well, and again, you cannot assume stuff is drawn to scale, okay? It's kind of tricky in that sense. So if this is 4 and this distance is 5, that is telling me that DE is 1. And I know it doesn't look to scale, and it isn't, but always trust the numbers over whether or not it's drawn to scale. Okay, so now I'm looking at this and I see that I have an expression already for DF. So DF is equal to 4 plus 3x. But I also see that I know both pieces of DF. I know this piece is 1 and this piece is 4x. So I can also say that DF is equal to 1 plus 4x. Now, we went over this in class, but if anyone wasn't there or forgets, if two expressions are equal to the same thing, I can set the expressions equal. So 4 plus 3x is going to equal 1 plus 4x. And now my strategy for solving linear equations is going to be get variables to one side, numbers to the other. So I'm going to go ahead and subtract 3x from both sides so that I get the variables on the right. Everything else I'm going to bring down. Bring the 4 down. Now variables are on the right, so I want to get the numbers on the left. Technically, I don't need this 1 in front of the x. So subtract a 1 from both sides. Cancels. 4 minus 1 is 3. So x equals 3. Alright, let's see. Okay, so number 10. These problems are a little tricky. You've got to kind of think, how can you write expressions for maybe things you don't know yet? So LK, I'm looking at this and I'm thinking, okay, well, I know this is 21 and I know this piece is x plus 7. So if I want to find LK, I would be doing, well, it'll equal 21, the whole thing, minus this piece, x plus 7. You do need to put that in parentheses, and I'll show you why in a minute. And then I'm going to write another expression for LK, and I'm going to use this information. So the whole thing here is 16, and the piece that I'm going to take away is negative 3 plus 2x. Alright, now I'm going to simplify these a little bit before I set them equal to each other. This is why the parentheses matters. When you're subtracting something in parentheses, you're going to have to distribute that negative sign, basically. So this would become 21 minus x minus 7. That's why it's important to have the parentheses. If you don't have the parentheses, you're going to get this wrong. Minus negative 3 turns positive, so that would be 16 plus 3, and minus gets distributed to the 2x. So now I can go ahead and set these two expressions equal, because they are both equal to LK. So we're going to have 21 minus x minus 7 equals 16 plus 3 minus 2x. First thing I do is combine. Alright, I see 21 as a number and negative 7. So 21 minus 7 is 14. So this side will become 14 minus x. 16 plus 3 is 19. oops, minus 2x. So I'm running a little bit out of room here, but I will add 2x to both sides. I'm going to actually do 2 steps at once here. That's going to cancel here, so my variables would be on the left, so I'm going to want to get the numbers to the right. So I'm going to subtract that 14 from both sides, cancels. Okay, 2x and negative x become 1x, and 19 minus 14 is 5, so we're done. Let's do one more, and I will save these additional problems for you to practice at home if you would like to. You're going to get a lot of practice with this in class. So let's see here. Okay, again, this is going to be a very similar thing. I'm going to write 2 expressions for CD because I know this whole piece, BD, and I know BC, so I can subtract the whole thing from this piece. So I'm going to do x plus 28, oops, minus 2x plus 29. Notice how I put that in parentheses. Let's simplify this real quick. This would be x plus 28 minus 2x minus 29. Now, maybe we could combine stuff here. X and negative 2x is negative x, and 28 and negative 29 is negative 1. You don't have to simplify it all right away. I think it's going to be easier for me, so I'm going to do it that way. And then this, oh, this is easy. Well, CD is also equal to 15 minus 6. Oh, wow, that's nice. What is that, 9? So now I'm going to set these two things equal. So negative x minus 1 equals 9. Add 1 to both sides. Negative x equals 10. That means x equals negative 10. And we are done. I am going to stop the video here. I really encourage you to try numbers 12, 13, and 14 on your own. It's great extra practice. Otherwise, I will see you guys in the next video.